In this problem, we're given information about how the heights of women and men are distributed, and it says that most of the live characters employed at an amusement park have height requirements of a minimum of 55 inches and a maximum of 62 inches. So in part A, we find the percentage of men meeting that height requirement. So how we're going to do that is we have our distribution of men's heights with a mean of 67.2. And so we're going to put that minimum at 55. And that's going to be somewhere way out here. When we look at the standard deviation of 3.4. And the maximum height is 62. So that's going to be, I'm just going to estimate it at about here. So I just need a rough sketch. It doesn't have to be perfect. And what we're trying to do is find the area under the curve between those two values. So how we do that is we calculate normal CDF, put in our lower and our upper limits, or the left and right hand limits, and then the mean, and then the standard deviation. And when we calculate this, we get 0.0629, which is 6.29%. So we've got that, and that would indicate that most men do not meet that height requirement, so most likely most of the characters are actually women. So if the height requirements are changed to exclude only the tallest 50% of men and the shortest 5% of men, then what are the new requirements? Okay, so I'm going to clear what I've drawn already. So we're still looking at heights of men. We want to cut off the top 50%. That's easy enough to do because that upper limit is going to be 67.2. And then we're going to cut off the bottom 5%. And I'm going to say that's roughly here. That's about 5%. This is about 50%. So I want to find out what value this is. I know that the upper limit is 67.2. That's easy enough to read off the graph. But how do I find this cutoff for the bottom 5%? This is where I'm going to use the inverse norm formula because I know the percentage on the left, and that is 5%. And then I put in the mean and the standard deviation, and that's 67.2 and 3.4. And that gives me 61.6 rounded to one decimal place. So that's how we would find those height requirements. Suppose that we didn't have the top 50%, so it was falling at a convenient value. Then what I would do is say, well, what percentage falls to the left of whatever this cutoff is? And because this is 50%, I would do 1 minus 0.50 and get 0.50. And then I would do inverse norm of 0.50, 67.2, and 3.4. And that would, of course, in this case, give me 67.2. So you can check and see that, but it's not really necessary to use the calculator to find that. So that's how you do that problem.